Okay, Common Core Geometry kids, this is Unit 9, Lesson 4, Tangents and Circles. Okay, there's just a couple of theorems that are going to be in this video. Most of the problems are going to be worked out in class. All right, so the first theorem is if you have a circle and you have a tangent drawn to a radius, it is perpendicular. Okay, so the theorem, sorry about my dog, if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. Okay, so if a line is tangent to a circle, it is perpendicular to the radius drawn to the point of tangency. Okay, so this is perpendicular. That means the Pythagorean theorem is going to come up. Anytime you see perpendicular, you can assume the Pythagorean theorem. All right, now obviously a radius is half of a diameter, right? So let's say you had a full diameter and you had a tangent drawn to the diameter, same thing. That would be a right angle. Okay, the other thing that this demonstrates is, if you recall, in our last video, we had a secant line. So a diameter is part of a secant, right? And then if you recall, we had a tangent drawn to that point of contact. And one of the things we discussed is that if you have an angle formed by a tangent and a secant, it's half of this inscribed arc, right? It's half of its intercepted arc, excuse me. So this is 180 degrees. Sorry, this dog is so distracting. Hold on. All right, so I thought about deleting that, and I said, you know what? It's good for you guys to see that your teachers are real, too. So, yeah, he was driving me crazy. I don't even know what he was barking at, but at any rate. So when you have an angle that is formed by a tangent and a secant, we discussed this in the last video, that angle is half of its intercepted arc. So it makes sense that this angle would be a right angle. Okay, not only that, it also makes double sense now, because here's a radius drawn to a tangent. And when you have a radius drawn to a tangent, it forms a right angle. Okay, so these things work simultaneously, all right? Okay, one other thing I have to tell you about tangents. Okay, something we call the hat theorem. Let's say you have two tangents drawn to a circle. Okay, and they're intersecting outside the circle. Those tangents are congruent. So that's going to come up all the time. All right, and we could certainly prove that if we wanted to. Maybe it's worth you guys seeing. So let's say we have a radius drawn to here and a radius drawn to here, right? These are right angles. Then, obviously, radii are congruent, reflexive property. So by side angle side, these two triangles would be congruent, and then these pieces would be congruent by CPCTC. Okay, so the theorem is that if you have two tangents drawn to a circle, from the same external point. Then those tangents are congruent. Okay, so we're going to be working on this during class. This leads to quite a few things. All right, but nice, simple, short video for you. So when you come into class, you are already having a clue of what's going to be going on. All right, that's the point of a flipped class. Okay, kids, thanks so much.